Hey y'all. It's been a minute. I went to Canada with my parents. Very good, very good. And so now we're gonna do a little bit of life hacking on some stuff. Okay, got it. Okay. Oh hey, it's Aniwa. Yay, airplane times. I love airplanes. One of my happiest places. Anyways, so we've got a bunch of PRs up into Spark proposed right now, and so we want to address some of the PR comments that came up. So I'm gonna close. Well, let's go the the view over here. So and then let's terminal view. So here, yeah, we're gonna close this union determinism fix because I don't really know, and I don't want to super deal with it. It's weird, and YOLO. This is the one that we're working on right now mostly. It's a void double filter eval um, during pushdown with projection pushdown, right? And it's relatively simple. Um, and sort of some concern here is so we've been going back and forth with CloudFan on this. Um, yeah. The first. Okay, cool. The first issue we encountered was necessary expressions and filter expressions causing the plan to become too large, resulting in driver out of memory errors. Performance is also an issue. Okay, let's go ahead. Let's go ahead. It will reduce the amount of duplication, but it does not completely remove it. For font size issues, that's probably better handled in a separate PR. We can add more heuristics around when to copy and when not to copy the expression. Um, cool. So yeah, this conversation has been going on since at least April 2024, and actually I think if we go back here, yeah, April 1st, 2024. So we've been trying to solve this problem for a long time, and this problem was introduced in Spark 3.0, I want to say. So it's been a problem for a long time too. But that being said, we can probably hack on it. We can probably make this better. I'm gonna put Discord because don't need that running right now. So let's go ahead and make sure we do. Um, uh, yeah. Okay. So now here, we gotta check out this branch. So let's go ahead and do that. Git checkout this branch here. And so CloudFan really wants this split into two separate rules. So we're gonna go find this two. Yeah, and I think he's wrong. And to be clear, like I think he's wrong. That doesn't mean he is wrong. Um, and that is if we split this into two rules, we're essentially going to have to do many more passes over the logical plan just because of how optimizer rule evaluation works. And so I think it makes more sense to try and push all of the filters down or not inside of one optimizer rule. So it's we do less passing back and forth between optimizer rules. So yeah, I think this is a bad idea. That being said, I think it's a bad idea, but I do hear him with his concern that the code is too complex. That is a legitimate concern, and we should try and make it less complex. And so, in fact, um, that's something that we've got. So git cherry pick. Okay, cool. And so I was working on this on the plane yesterday. And so essentially what this tries to do is split the rule. It still remains inside of one rule, but the logic is sort of split. And so I'm hoping that that's the okay trade-off. Time will tell. So let's go ahead and we're gonna go and find our thing here. So let's go. This is called optimizer.scala. Okay, and fold out. All right. It is dot fold out, right? Okay. You have to reload the file. Yeah. Okay. So here we go. So there were some dots because I was on the airplane and I was kind of lazy and I just wanted to like get the logic written down. Yes. Okay. Oh, I feel like there's actually. I feel like I actually got a little bit further than this. I'm gonna double check on my laptop and see if maybe I didn't push the absolute latest code. So let's go ahead and double check that first before we start making changes. But essentially, the part of his comment that I did listen to is like, hey, this logic is kind of interwoven and it's difficult to follow. And so we've got case 1 and 2. And so in case 1 and 2, we push the filters with copies if necessary. And so in case 1, there's no copying needed, so it's totally fine. And in case 2, there is copying needed, but it's relatively inexpensive, and so that's where we do the push. And then case 3 is sort of the more complex one. Case 3 is the situation where we have an expensive filter. We don't want to push it, right? Or we can't push it, but well, sorry, we don't want to do any copying because then we're going to double evaluate the expensive component of the filter. Well, maybe that is actually the latest. Did I? Oh, yeah, okay. Okay, there's a tiny bit more, but not much. I maybe got a little bit further in my head than I actually got in code. That happens from time to time. So get fetch. Oh no, that's not the right. Get fetch origin. And then what we're going to do is get log. And get cherry pick. And it's over to our branch here. So, and we're going to reload it. Okay. So, yeah, there we go. There we go. And actually, yeah, so this is, we want tail. And okay. We do this to fold. If there's only one though, we can just directly do the split in a simple way. So only only one split. We don't need to do any complex tracking. Okay. So if there's only one split, then what we've got here so old logic more or less said, so we're gonna have this like list of used aliases. So we are going to make a filter. Okay, yeah. So yeah, what we do. Yeah, so here, filter, expansive filter cond. Over top of peak pushed. But then we also need to do, yeah, okay. Yeah, there we go. Project dot copy project list is equal to projection references, expensive filter aliases. So that should give us yeah, so we'll set this to used. Seem right. Child equals push project.copy unused. Here we now have projection unused. Unused refs, filter, projection, use refs. Keep push, copy refs. Okay. Or do we actually want to, okay, added aliases is the set of aliases. Oh god. Okay. That shit's confusing. I really wish the old logic was good enough. Is it though? Maybe. I don't know. Um, although actually, maybe actually we can just not bother with this part. Um, the tail. So you split on tail. Field left, foul. Um, filter to split dot head. Um, um, hmm, project.copy. Um, okay, so okay. The first filter. Okay. No, because she pushed. Yeah. Okay. I'm gonna go find field. Alias names. Remaining aliases to eval. Push alias names. Um, project copy project list is equal to our child, who's going to be cheap pushed dot output plus plus to split. Okay. Fucking. Um, So head dot yeah, so those are all of our aliases. Oh, okay. Filter not added aliases dot. Okay. Does this seem right? Probably. Maybe. Okay. Okay. So our initial value is going to be first. So, what we've got now is B comma A. So case current filter, and then next used, next cons. Head dot underscore one. New aliases. Next use dot filter and added aliases. So actually, we can get rid of this logic here. There's nothing for us to filter on, really. Here there is. Okay, so then if new aliases dot is empty, we've already have all the aliases needed. So there we go. Filter next cons dot reduce and current else. It's actually pretty correct. It looks fine. Okay. So it's here. Okay. So yeah, this already is the else case. Okay. Now, here we go. So, really? You're saying that doesn't make any sense to me. What do you match? if expensive with used is not empty. Okay, actually, yeah, fine. Now, okay. Now, see if we need to insert a last. Ah, yeah. Um, uh, I don't think we need to convert it to a map, though. Yeah. Left behind aliases. Project output filter. And then right here. Project copy, project match, column, ordering. There we go. Fields, and then expensive split dot output. Left behind aliases. Okay. Yeah, okay. Files equals expensive split. Cool. Okay, this is insert a last projection to match the desired column ordering. And what else are we doing? And evaluate any stragglers. Cool. Now, is this going to work? Oh, hell no. But it's like a fairly logical-ish place. Go ahead and have our compiler yell at us and tell us to fix up our types. Now, we could conceivably we could match the target ordering in all of our intermediate projections and filters, and then we might not have to introduce this projection. Hard to say if that's the right thing to do or not. I don't think so, but like, who knows, right? Really, it's fundamentally what it comes down to. Um, Shoot. Mm. Okay. Doesn't like the Scala style, which I don't really care about right now, but the thing that I actually want is what our errors are. Ah, expensive by used. Okay, line 2145. Actually, do we need that? Do we need to group them together? Um, uh, we don't. With the way how we've done this. Although, there's no harm in grouping them together. Ah, okay. Um, yeah, okay, that's gonna need a little bit more TLC. Okay. So now we want to do uh list. Um yeah, so I think we'll just take um expensive with used group by underscore dot underscore one. Okay, cool. Um the problem here though is okay. So then let's go ahead and write these types. Okay. We're gonna write some fit types here, and the compiler's gonna yell at us. Um, eh, but we're gonna use this to like figure stuff out a little bit more in a more concrete way. Cool, 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 cool. Come on, compiler, please yell at me. Fantastic. Okay. Go up to the top. Okay, optimizer.scala line 2102. Hey, Cobra.
Baby.
Oh, hey, baby size. Oh, hey, did you need attention from second favorite? Oh, he seems happy.
Well, I think
Oh, is it the BALL?
it's working time.
Yes, but have you considered that instead it could be Professor Tom? Yeah, neither do I. It's one of my life goals.
It happened to me once. Like,
Oh,
kinda.
yeah, I mean, so more than once.
I've had a few companies lose money.
You know what else? Oh, you think I need to pick him up? You think I need to pick him up? No. Okay, but the idea here is essentially I don't think that's something that he really gets. Ah, it's SQLconf.get. Okay. Okay. Um, set a type alias, right? Expensive filter alias. Okay. Expensive filter aliases. I don't think we use that. Okay. Um, that are used aliases for. That's not what this is anymore, is it? Okay. Um. Ah. I think we actually want the condition along with the aliases, right? Yeah. Um. Yeah. Okay. There we go. Avoid double. Oh, fuck. Let's go find SQL comp. Eval. Yep. That is a typo. Eval. Okay. Mm. Okay. And so let's go ahead and give you a type. Sequence of type expression. Set of type alias. Tuples. Okay. Mhm. Um, Mhm. Oh, wait, what? Oh, okay. So, and then we got the um, um, okay, I found an attribute map. Attribute map. Um, so it's an attribute map of type alias. So what it is it um okay, so if instead here we gave it attribute map of type alias, and then we go here and we go attribute map dot empty alias. Okay. Attributes map empty alias and then used aliases. Fantastic. Optimizer dot style. So okay. So split conjunctive predicate, use aliases for condition, partition on condition and use. That seems reasonable. And you're saying you found a sequence. Split conjunctive predicates is okay, so we need to do that earlier. Right, because up here we've got used aliases for conditions. What we actually probably want to do is we want to split the conjunctive predicate here. Because, you know, if there's a bunch of and conditions, we can do things more creatively. Okay, cool. 2112, fantastic. So used alias for condition is a sequence of expression to attribute maps of aliases. That seems fine. So if we are avoiding double filter eval, immediately everything's cheap. The expected type requires a one argument function accepting a tuple. Oh, I forgot the, there we go. Cool. Zero. Yeah. Expression. Wait, that's right. Yeah. So if we don't, okay, yeah. So by default, okay, and so actually, is this the right base case? So by default, what we do here, so cheap push could be this. We don't have any inexpensive filters to push. It's just the grandchild. Okay. Base 3, and then over here is where we put our final projection on. Okay, yeah, that looks better. Yeah, cool. 2136. You're just an expression. Similarly, you are an expression. Oh. Cool. So 214. Expensive by use. 2144. Let's go find that. Filter is an expression? No? Why is a filter not an expression? Yeah, okay. Okay. Not an expression. Logical plan. Similarly, you are a logical plan. And then expensive by use is going to be 240, 2144. It is a map of wait, what? Does that seem like what I want? Okay. Expensive with used. Let's go double check what expensive with used is. Optimizer dot expensive with used. Okay. So this should be expression attribute map alias. And so we actually want to group on attribute map alias. So we want to group by underscore dot underscore two. Right, so string no. Okay. This is a map of expression alias. Fantastic. Okay. Attribute map. Alias. So this should be a map of attribute map alias to a sequence of type expression. So essentially we're grouping all of the expressions together. Now this does depend on attribute map having an equality operator. Okay. Yeah. Oh. Okay, it says it found a map view of attribute map list, which is fine. Okay, so I guess let's go map view. Um, Scala.collection.map view. Okay. Import scala.collection.map view, right? Or is it? Okay, now we need to also make a set of all aliases. That seems fine. And we should make that up here. What are all of our aliases? Yeah. All aliases. Map alias. Um, oh, it's just alias map, I want to say. Okay. Um, cool. Cool. That's got a shot. Um, okay, 2164. And let's just use attribute map alias. Um, yeah. Ambiguous reference. Apply. Okay, 2164. No, attribute map empty alias. Oh, except, is that right? So, what we would want to do yeah, that's probably right. Because we won't have added any aliases in our cheap code path. Right. Okay. 2168. Okay, project list. Project.copy. Cheap push.output plus head underscore one. Okay. Let's go ahead. Head use, head cons. Okay. Cons. Okay. Still gonna fail, but it'll hopefully give us like a bit more of a clear understanding. Okay. So, okay. So we want to go from attribute map of alias to named expression, right? Um, um, expensive filter aliases. So, and how do we compute expensive filter aliases? Or, ah, okay. Used aliases. Used alias. Wait. Okay. Because what we did is we would take the used aliases and we just go ahead and grab underscore 2. Okay. Let's see if that works. Okay, okay. So, yeah. Start off with using okay. Found attribute alias required attribute. Okay. That's fine. 2127, 21. Oh, wait, no, 2172. Okay. And that's great. So, X are left behind aliases. Project.output.filter. Okay. Hmm. Found a mutable map. The 2179. Is that where I am? Nope. Let's go 21. New aliases. Ah, here we go. Required named expression. Yeah. Ah, it's alias. 2181. Okay, so new aliases dot for each. Aliases dot add except attribute map. Um, ah, okay. This. Okay. So, find added aliases. You are going to be a bar, my friend. So, added aliases is equal to new aliases dot old left added aliases yeah, fine. Right, because we've got our contains a attribute. Oh, I'll be right back. I got it. Okay. Okay. Pretty reasonable. I don't love it though, because we need a. Okay. Okay. Um. A. Well, new aliases. Uh. New attribute aliases. Down. New aliases. New attribute. Okay. And then here, new attribute aliases. Okay, I don't. Okay. this. Okay. Update our edit aliases so we don't have them again. Cool. So let's go find this. This is mad about. Oh. 1 second. I will be right back. Got a phone call coming in. And then I'm also going to do a quick bio break. Hello, this is Holden. What's up? And we're back. Okay, 7 warnings, 1 error. So it doesn't like this. Method map value and trait map ops is deprecated. Okay. And then there's a bunch of long ones. Okay. Ah, okay. No, there can't be. Okay. Fine. 2101. Okay. Let's get rid of the type annotation. We don't strictly need it here. It's just for like my thinking about stuff. Um, Similarly, I guess here we can get rid of the type annotation. Well, we can lint it a little bit later. What do I do? Do I want to push it to another branch? Maybe. Part of me does. Just because, you know. Eh. Um. Yeah, let's push it to another branch. Um. Question is like, which of these two is actually cleaner? And I don't really know. Um. Well, let's make a git commit at least. Do do do. Well, okay. Git add SQL. Fix typo and avoid in val. Okay. Try and rewrite the logic to be more readable. And what are we doing? Try and rewrite the logic to be more readable and clearly broken down into the possible cases separately. Cool. And yeah, okay. 24 tests failed. No shit. So like, no. So like we did the rewrite. I don't like it. I don't like it, and it. Ah, tests don't pass. For one thing. So, um, we've got this leave as is group. Do we do anything with leave as? Okay, we don't. Don't. So leave as is. These are ones which we're not going to do anything with. Okay. So you match with the case where if expensive with okay, well, so first things first, we can simplify this a little bit. Um, um, expensive push. Let's go expensive split. And then about top projection. If leave as is, dot is empty, dot projection. Else finally filters which could not be pushed or splits. Yeah. Right. Okay. Oop. So, oh, okay. 1 second. Another call. I'll be right back. Okay. Back we go. Yeah. Okay. So this is match column ordering. Match column ordering. Doot, 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 doot. So expensive split dot output set dot contains. So match column ordering is saying it can't find this. Um, that's weird. Use alias. Okay. Is this all going to be? It's all match column ordering. Index 5 is out of. Okay, let's go take a look. 2065. Match column ordering. Do 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 do. So we've got our original, which is a sequence of named expressions, and our updated, which is a sequence of named expressions. Let's go. Match column ordering. Project dot output dot filter. What the fuck? Okay. Matching. Hmm. Oh, yeah. Okay, yeah. Wait, does this, let's go see where else I use match column ordering. Okay, how do we used to use match column ordering? Okay, match column ordering. Remaining aliases to eval. Remaining aliases to eval is left behind aliases dot iterator dot. So A0, B1, C2, and then we've got these windows have been added in twice, and we also have this W310. This window's been added in twice. That window's been added in twice, and we have this extra W310. Okay. So somehow so okay, our project list. Projection references. Projection references. Oh, okay. Project list dot oh, yeah. Yeah. Okay, so we do need to actually filter our references too. 217. Okay. Right. Um, so, okay, so cheap push. If cheap is not empty, okay. Cheap push. Then, cheap push with only relevant recs is logical plan. If push dot output set dot subset sets. So if put output set, yeah, okay. project output set. No change needed. Push counts. Add a projection to narrow the output to what we need. Project.copy project list equals cheap push dot references dot filter no project dot references dot contains. Okay. And then it's for okay. What? Oh. ADHD strikes. Yeah, really, just graphic dyslexia strikes again. Logical plan. Hello, this is Holden. Uh, all right. Um, okay, found attribute set. What? Cheap push references filter. What the fiddlesticks? Okay. Fine. Okay. Okay. Keep push only relevant refs. Okay. References. Okay. That's found in project. That's found in production. Like this just doesn't make sense to me. Typing. Okay, you're saying that's the type here. Keep push dot references. What the actual thought? Okay. So um so okay. Yes. Fantastic. 217. Um new projection. Hmm. Scope down the data coming from the grandchild, if we can. Alright, so 24 failed tests, but hopefully it makes a little bit more sense. So what have we got now? So now, okay, let's go take a look. So here we go. We've got our local relation. Fantastic. And then we do this projection, which is to say, um, complex predicate with different expression. Oh yeah, this is definitely not what we want, is it? Like at all. I miss my old logic, the one that I thought through for a really long time. Okay. So let's go through this now. Oh, it's 2:30. Okay. You know, this is great. I think I'm going to wrap up for today. Um, use the analysis for condition. So, Alexa, create a 10-minute timer.
10-minute timer started.
Alexa, how long's on my timer? So
your timer has 9 minutes and
okay, never mind, don't worry. So here we go. So that's our first check. It's the alias map. This is, we split our condition. Otherwise, yep, that looks fine. Now here is where we partition it into expensive and cheap. Fantastic, cheap with used. If the cheap outputs, that makes sense. Otherwise, we filter it down here. Okay. Do group by unused aliases. So if we have two filters, we have multiple filters with the same aliases, we introduce them together. Okay. I think it's fine. So our references. Ah. Okay. Yeah. Okay. Dot filter. With only relevant graphs. Output set dot. Yeah. I think we don't need the filter here because, yeah. So here, um, the aliases, existing, a bit of a hack. See if it'll. Uh, so essentially, the idea here is that the idea here is we're introducing things into this that don't make a huge amount of sense. Let's actually just narrow it down for now. Find aggregate push down filter with literal. This is probably different from just this test. That'll give us a good idea of what's going on. Okay. So here, what we're saying is the plan isn't equal. So we've got filter. Yeah, that doesn't work. Right? We can't move the filter. Can we? Push down. To be clear, we are only in the case where it's a filter with a condition over top of a projection. So, filter. Okay, let's go find filter pushdown speed. Okay, so our original query is select A and B, and then we group by this, and then we've got a filter where C is equal to 2 and D is equal to S. And so this says the correct answer has S pushed all the way down to the bottom. Oh, right, because S is equal to, S is a constant. Filter S equals S. And here we've got filter but like that should be a constantly evaluated filter, so why isn't it getting folded away? So, okay, local relation ABC0, ABC0, filter S equals S, that should be able to be removed. Right, that's a no-op. Yeah, that's a no-op. So, okay. What the hell? Alexa, snooze.
Timer snooze for 5 minutes.
Here, what we've got is window, no predicate pushdown. Okay. Window, no predicates are not from partitioning keys. So, what? We've got local relation. You're saying that the correct answer is, but the partitioning key is A comma B. What? Original query, ABC, and then we window, and then we filter C is greater than 1. And you're saying, so ABC, window, project, window 0, window 0. Okay. Yeah, so something's wrong here, right? We've got Windows 0 introduced twice. And this is happening presumably at the top case. Right, local relation, project, window, build. So cheap with used. So these should all be cheap. So we will push it. We'll have our filter, but there's no. We've got our filter window spec. Oh yeah, okay. This is some crazy shit. Tell you that. I really preferred the other one. Top level projection is adding oh, it's not coming from that one. Alexa snooze. Okay. It's not coming here.
Got it. Timer snoozed for 5 minutes.
Um, okay. Um, Okay. That's the projection. Where's it coming from? Okay. Doot. Split projection, refactor, attempt. And then, okay, narrowing to. Ah, okay, okay. Um, distance. Um, Alexa snooze.
Timer snooze for 5 minutes.
Hmm. Yeah. Uh, okay. There we go. I think maybe a line 2155. mean, that should actually, whatever. I really don't like this. We'll push it, and I'll think about it. Okay. Eh. Okay. So here, we'll get that branch, and so what we'll do here is we're gonna go up here. Yeah. Okay. At Cloudfin. Yeah. I did some exploring around separating out the logic. It's still kind of rough. It's still kind of rough. It's still kind of rough. And where's the new branch that we just pushed to? Here we go. It's still kind of rough. It's still kind of rough. I will give a bit more thought on cleaning this up in another way, or refactoring. Improving the dogs. Alexa, stop. The little logic up doesn't really help. Although feel free to take a look at this branch and see if you prefer. Cool. So that's my yeah, I don't think this is the right thing to do. We did a solid try. And cool. We're gonna go back to the thing that I was doing before though, because I prefer that. That's gonna be what I do. And now I'm gonna go and not work on Spark for the rest of the weekend. Bye y'all.